In previous lectures we have considered empiricist attitudes towards science, as well as some of the difficulties that have confronted empiricists. A very different kind of challenge for empiricist attitudes emerged with the work of Thomas Kuhn, who was particularly concerned with looking at the history of science and trying to draw morals about the nature of science, how science works, by reflecting on the nature of the history of the discipline. So this emphasis on historical perspectives is apparent from the very beginning of Kuhn's most famous book, which was called The Structure of Scientific Revolutions. At the very beginning of that book, Kuhn announces that, in his view, history, if viewed as a repository for more than anecdote or chronology, could produce a decisive transformation in the image of science by which we are now possessed. So that image of science that Kuhn is talking about is the empiricist attitude. So Kuhn is here expressing his conviction that the history of science could transform our view of how science works. Kuhn continues that image, so again he's talking about the empiricist image, that image has previously been drawn even by scientists themselves, mainly from the study of finished scientific achievements, as these are recorded in the classics and, more recently, in the textbooks from which each new scientific generation learns to practice its trade. Inevitably, however, the aim of such books is persuasive and pedagogic. A concept of science drawn from them is no more likely to fit the enterprise that produced them than an image of a national culture drawn from a tourist brochure or a language text. This essay attempts to show that we have been misled by them in fundamental ways. Its aim is a sketch of the quite different concept of science that can emerge from the historical record of the research activity itself. To understand Kuhn's project, it's useful to distinguish his critique of empiricism on the one hand from his own original novel contribution to our efforts to understand how science works. So on the one hand we have Kuhn's challenges, on the other hand we have his own replacement theory. Among the challenges was Kuhn's observation that science isn't straightforwardly cumulative, and thus, insofar as perhaps empiricism might have given rise to the idea that science just accumulates more facts, that science progresses just by growing the number of facts that we have at our disposal. Insofar as empiricists might have promoted that kind of view, then Kuhn argued that history of science reveals that this is inadequate, that this is misleading. Science isn't straightforwardly cumulative. There are lots of things changing within the history of science. Scientists ask different questions at different times, they have different methods, they work on the basis of different assumptions, and often this requires revising and revisiting older ideas. So this notion of a cumulative pattern within the history of science just isn't apparent. Going along with this idea is Kuhn's view that the history of science suggests that progress, scientific progress, isn't the result of simply employing a single, unchanging, unifying scientific method. That methods change from one period to another, from one discipline to another. Now this conclusion of Kuhn's, that there is no scientific method, no universal, unifying scientific method, was quite disconcerting, quite shocking, quite radical in the 1960s when Kuhn was proposing this idea. And part of the reason that this seemed so radical, part of the reason that it seemed so hard to accept, was that a lot of other notions concerning science seemed intimately connected with this notion of a scientific method. So, insofar as people thought that science was more rational, its conclusions more objective, and that it was capable of making genuine progress, these were all attributed to or understood in terms of the scientific method. Science was more rational because of the scientific method. Science was more objective because of the scientific method. So if it turned out, as Kuhn argued, that there wasn't really such a method, then it became unclear how we could continue arguing that or accepting that science is more rational, for example. So these challenges are important to try to understand. Simultaneously, and what we'll focus on more in this lecture, is Kuhn's replacement theory. So Kuhn wasn't just looking to overturn existing attitudes toward science. He wanted to promote his own view about how science works. And this relied centrally on the idea that science takes place within frameworks or within paradigms. So understanding Kuhn's own theory of science, his own account as to what science is and how science works, relies heavily on understanding his notion of a paradigm. For Kuhn, these frameworks or paradigms define what science is and how science is to be done within periods of what he calls normal science. Now, these frameworks or paradigms are occasionally overturned, they are replaced, but this doesn't take place within normal science. This takes place within what Kuhn calls revolutionary science. So, to understand Kuhn's theory, we need to understand both more about what he means by normal science and what he means by revolutionary science. Normal science, for Kuhn, is always inspired by some particular scientific achievement. So something emerges within some community, and these results or these methods are appealing and intriguing to members of that community, and they want to try and emulate this achievement. They want to develop it. They want to understand it better. They want to refine it. And by admiring this work, this achievement in the way that they do, and by wanting to develop it, by wanting to refine it, they end up adopting a lot of the methods and strategies that were apparent and explicit within that initial achievement. So those who follow in the footsteps of whoever it is that made this initial accomplishment adopt the same kinds of strategies. They accept the core parts of the theory. They adopt the same understanding as to how science within this discipline should be conducted. And part of the reason for pursuing science in these particular ways is the sense that this is a promising way to conduct science. This is a promising avenue for future research. And so their hope is to try and solve any puzzles or difficulties that emerge within that framework. Revolutionary science, as mentioned, involves the replacement of one paradigm or one framework with another. Once that has been completed, then normal science can resume But now science looks very different. It's normal science again, but it's sort of under new management. One of the criticisms of Kuhn's work was that he wasn't always very precise with the language that he used. And this is particularly apparent with the way in which he uses the word paradigm. So you can see here on this slide that Kuhn uses the word to mean quite different things. He uses the word paradigm to refer to the initial achievement, but he also, and more unusually, uses the word paradigm to refer to a framework or a worldview, a set of ideas that tells us how to do science. We can develop Kuhn's account a little further by recognizing a couple of other important concepts or phases within Kuhn's theory. Prior to any period of normal science, there will be for Kuhn a period of pre-paradigm science. Furthermore, as normal science unfolds, anomalies will accrue within that paradigm, within that research program, and these will eventually lead to what Kuhn describes as a crisis state, which is one of the important prerequisites for revolutionary science. Kuhn regards pre-paradigm science as disorganized and unproductive. The reason that pre-paradigm science is unproductive, according to Kuhn, is a result of it being disorganized, a result of the absence of shared ideas within some particular scientific community. So Kuhn claims historical evidence for these periods within scholarship, within investigation. Periods when people were trying to understand the nature of heat or light or electricity or magnetism, but they were confronted with a confusing array of phenomena and data. And different groups or different individuals or different schools had different ideas about how to further our understanding, about how to generate significant and interesting theories or accounts of these phenomena. So, because there was such disagreement about what methods to use, about how to evaluate one another's achievements, about what it was exactly that groups were trying to do, because there wasn't much consensus on these kinds of issues, then it was very, very difficult to make any real progress, according to Kuhn. So it was that lack of organization, that lack of unification, that is responsible for the lack of productivity, the lack of output within pre-paradigm science. As one illustration that Kuhn likes, we might think about the nature of light. How are we to think about light? What kind of thing light is? What's apparent, if one goes back far enough in the history of optics, the history of efforts to understand the nature of light, is that for a very long time there were very, very different ideas about how to even get a theory of light off the ground. So this looks like a good example of pre-paradigm science. What will often emerge from a period of pre-paradigm science, however, is a period of normal science, according to Kuhn. And so this is, as we've already noted, inspired by some particular achievement. This achievement is perceived to solve some particular problems within the area particularly elegantly, perhaps, or perhaps it solves a larger number of problems than alternative approaches to scientific inquiry. Something recommends this particular approach and set of assumptions, and this fairly quickly, according to Kuhn, has the effect of galvanizing a scientific community, unifying them behind a set of shared assumptions and ideas. And so that changes things This achievement changes the social structure of the scientific community from one of being disorganized to one of being much more highly organized and congregated round or held together by a set of shared assumptions. So a paradigm for Kuhn isn't just a theory about what the world is like. It's not just a scientific theory, although theory is certainly a big part of a paradigm. But in addition, a paradigm tells practicing scientists how to do science, what kinds of questions to ask, how to go about answering those questions, what methods to use, how to gather data, how to evaluate hypotheses, what to value, what to be suspicious of. All these kinds of criteria that are important for doing science are defined within the paradigm, and therefore they define normal science for some particular community at some particular time. So what this means is that normal science, according to Kuhn, proceeds without challenging certain background assumptions. There are certain things within the paradigm, certain attitudes, certain principles, certain convictions that members of that community don't question. It's not part of the game. It's not part of their discipline to challenge these certain assumptions. What is involved in normal science instead is what Kuhn calls puzzle solving. So scientists within normal science are trying to resolve certain puzzles. They're trying to answer certain questions. There's an expectation that these questions are answerable. These puzzles can be solved within the paradigm without having to be too innovative or without having to challenge the background assumptions. And so in that respect, Kuhn thinks that there are analogies between the work of normal science and what we would think of as puzzle solving when you think of crossword puzzles or Sudoku or jigsaw puzzles or whatever it is. We've now talked in this lecture about pre-paradigm science and normal science, as Kuhn uses these terms. For further information, you should of course refer to the text, which also includes some examples of normal science. Within normal science, puzzles will emerge, and sometimes normal scientists will find the resources or insights to resolve those puzzles from within the paradigm. But sometimes solutions to puzzles are going to be hard to find. These are anomalies. An anomaly within science is some observation or phenomenon which scientists feel they should be able to account for or should be able to explain, but thus far they're unable to. So it remains an anomaly, something unexplained. For some time at least, according to Kuhn, normal scientists will tolerate a certain number of anomalies. They will remain optimistic that their paradigm, their assumptions are on the right track, and that eventually a solution to this particular anomaly will emerge. But if anomalies persist for long enough, or perhaps if enough anomalies start to accrue, or perhaps some particular anomaly draws a lot of attention and just seems impossible to solve from within a particular paradigm, then according to Kuhn, a scientific community might enter what he calls a crisis state. Now, a crisis state and the sort of critical mass of anomalies that gives rise to the crisis state is one of two conditions that Kuhn says must be met in order for a scientific revolution to take place. The second condition is that a rival paradigm must emerge. When these two conditions are met, then a scientific revolution is possible, which commentators subsequent to Kuhn have talked about as a paradigm shift. This might be a phrase that you've actually come across outside the philosophy classroom.